Hey everyone, I'm Shuo from Northeastern University. Today I want to show our work on parametric misspecified Bayesian Cramér-Rao bound and its application to linear and Gaussian systems. So first I'm gonna introduce what is Bayesian Cramér-Rao bound and also what is misspecified Cramér-Rao bound. Then I will combine these two to introduce our main contribution in this work, the misspecified Bayesian Cramér-Rao bound. And also, we will do some experiment to show its applications to linear and Gaussian model. And based on the experiment and the simulation we have, there will be some conclusions in the end. So first, the BCRB, Bayesian Cramér-Rao bound, is used when we try to estimate an unknown random parameter with this model, for example, M star, which has a likelihood distribution and also has a prior information of the sign. The BCRB is the lower bound on the minimum mean square error in estimating such a random parameter. And the J here is actually the posterior Bayesian information matrix. It can be separated into two parts. One part comes for the likelihood distribution, and the other one comes for the prior information. And then what is a misspecified or mismatched case? So that means the assumed model we used for estimating is different from the true model, which is used to generate the data. So for example, assumed model here, M, which includes likelihood distribution, and it, with the parameter theta may be different from the psi we have before. So you can imagine actually the bound we have before is not effective anymore because we are not using the correct model to estimate it. In this case, people usually define a pseudo-range parameter, which can minimize the KL divergence between the P of x given psi and Fx given theta. And this theta zero is actually the best estimation we can have because it makes these two distributions closest to each other. And in this case, the MCRB can bound the error centered on the theta zero, as shown below in this inequality. But the problem here is that the MCRB can only be used for deterministic parameter estimation because there's no prior information in the assumed model, and there's no prior information in the bound actually, right? So what we want to do is to derive a misspecified bound, but in the Bayesian case this time. So first, we assume the model with the prior information. We add the theta follows the F theta, its prior information. And then based on this, we define a pseudo-true that minimizes the KL divergence between the P of x given psi and Fx joint theta. And there may be different pseudo-range definition, and they will result in different bound. But here, this definition depends on each realization of the psi. So finally, we aim to find a lower bound for this value, which is the error centered on the theta zero psi. And you can see the expectation psi here actually counts for the prior information we have. And then we go to how we derive this bound. So I don't want to talk about a lot of details here because you can refer, if you are interested in this, you can refer to our paper. I will only mention some key points. So first, there are two similar assumptions as the BCRB does, like the regularity conditions we have and also the prior distribution at the limit should be zero. And then we have this equation. Then we do a little trick by multiplying this A and B vector to use the Cauchy squared inequality. And finally, by picking this B and A properly, we can have the bound we want. And we call this bound MBCRB, stands for misspecified Bayesian Cramér-Rao bound. And then it goes to its application to the linear and Gaussian model. So psi and theta would be the parameter in the true model and assumed model. There is a distribution, there is a likelihood distribution following Gaussian, and also their prior information will also follow a Gaussian. According to the equation we have before, we know the pseudo-true will be like this, and we have the BCRB for it. And now let's talk about the particular parameterization in this experiment. So the true models, the parameter in the true model will be set like this, and as in the assumed model here, and in the following in the following stuff in this presentation. For the assumed model, I will only show the misspecified parameter, which means the parameters I don't show here will be exactly the same with the true model. So here in this case, we have the misspecification in the mean of the prior and also the covariance of the observation model. So you can see the RMSE of the estimation in this case would be the blue line, and the traditional BCRB cannot bound it anymore, but our proposed MBCRB can still bound it very well. Then there will be an extended biased bound if theta and psi belong to the same vector space. For example, here they are all three-dimensional. Then we can use this biased term, which is the difference between the pseudo-true and the true parameter. We add this biased term, then our bound can also bound the error centered on this true parameter, but not only on the pseudo-true parameter. And the result shows that our bound the RMSE very well. Then I want to talk about the different levels of the model misspecification. The true model, as I showed before, is looked like this. So H should be equal to 1 in the true model, but in the assumed model, when we have a varying H, you can see when H is equal to 1, we have the minimum RMSE, because at this point, the true model is the same with the assumed model. When the H is different, then the error will become larger as expectation, but our bound can still bound this error well. And the same thing happens when we try to when we have varying sigma square, and there's no such a minimum point, because whatever sigma square you use, the assumed model will be different with the true model, since the covariance in the true model is a colored matrix. Okay, but still our bound can bound the RMSE very well. So as a little summary, we defined a new pseudo-true parameter, and based on that, we propose an MBCRB, which is used for a random parameter estimation in the misspecified case. And this misspecification could happen in the prior information or the observation model. And as the experiment shows, this MBCRB is able to lower bound estimation error in the linear and Gaussian case. So that's all. Thank you for watching.